All right, so we are on review sheet 2. We're going to go through a few of the ones for today, day 4. You're doing 1 through 9. We're going to do 5, 8, and 9 together. On the front, you've got your two definition of the derivative setups. You can use either way. And then you got your mean value theorem as well. So we're going to start with number 5. So the only time you have to do the A way or the H way is if the question says use the definition of the derivative. If it doesn't say that, then we can do our regular derivative stuff that we've been doing all year. So I'm going to do the H way. So that would be limit as H approaches 0. So we have f of x plus h in this first one minus f of x all over h. So f of x plus h means in your equation, anywhere there is x, just replace it with x plus h. Okay, it does not mean add h on the end. It means replace your x's with x plus h. So there's f of x plus h. Minus f of x, well, that's just the original. And then all over h. And then once you have the limit set up, we just do it like our unit 2 evaluating limits. So in this one here, we're going to have to multiply by x minus 1, both top and bottom. And in this one here, we're going to have to multiply by x plus h minus 1, top and bottom. So this will then give us, make sure you rewrite your limit each time. We're going to have x minus 1 minus, and then a parenthesis, x plus h minus 1 all over our common denominator. And then I'm going to write the divide by h like this. So we'll come over here, we'll have limit, oops, as h approaches 0. If we distribute our negative of x minus 1 minus x minus h plus 1. Now when you do the h way, remember if you do it correctly, in the numerator, anything that does not have an h in it should divide out. And I'm going to switch this division to a keep change flip so it becomes multiplication. So it's a times 1 over h. So in our numerator, if we combine like terms there, the x's wipe out, the 1's wipe out. So we just have minus h times 1, which is just minus h. I'm going to throw the h down on the bottom here when we multiply those together. Well, now we can divide the h's out. So that's a 1. This is a negative 1 now. And now we can do our direct substitution. If we replace all the h's with zeros, we can just get negative 1 over x minus 1 times x minus 1. You could write it like that, or you could write it as negative 1 over x minus 1 squared. Now you have an advantage from when we first did these, and this would end up being y prime is what's equal to this. You have an advantage when we first did these in that you know the shortcuts now. So you could off to the side do the shortcut quotient rule. See if it gives you this. If it does, then you know you did it correctly. But the work you need to have is all of this work. So our other topic for today, other than the definition of the derivative, is related rates. With related rates, in general, you have some type of equation. Once you have that equation, anything constant can be subbed in before taking the derivative. Then you take your derivative with respect to time, and whatever you are looking for should be the only one that you can't sub in for. Everything else you should be able to sub in for. So we're going to look at 8 and 9. So we have an airplane flying at an altitude of 6 miles. It's flying on a flight path that will take it directly over a radar station. The distance between the plane and the station is decreasing at 400 miles per hour. When the distance is 10 miles, what is the speed of the plane? So let's say that this is our radar station here. The plane, we'll say, is here, and the distance between it and the station is decreasing, so we know it's heading this way. And what this ends up forming is a right triangle. This length is changing, this length is changing, but your altitude is staying at 6 miles. So the equation that naturally works out here is x squared plus 36 equals y squared. We have a rate for x. We know our dx dt is this here, and we're trying to find the, sorry, our dy dt is the 400 because it's the distance between the plane and the station. So we know our dy dt, and we're trying to find the speed of the plane, which is our dx dt. So you want to make sure before you take the derivative, you only have variables that you either know the rate, so we know y's rate, or want to find the rate. We want to find x's rate. If there's any others, then there should be some way to sub in for those other things. And we'll see an idea like that, I believe, in the next one. So we'll take our derivative with respect to time. So this is 2x times dx over dt. The derivative of 36 is just 0. And then we get 2y times dy over dt. We want to find the speed of the plane, which is dx over dt, meaning we should be able to sub in for everything else. So we've got 2 times, we'll do the easy ones first. So our distance is 10 miles, so that's our y. Our rate is 400 miles per hour. They said it's decreasing, so we need to put that in as a negative 400. It's for the rates you're subbing in, it's always up to you to decide is it going in as a positive or a negative. They're never going to tell you that. They're always going to list it as a positive and just let you know if it's increasing or decreasing. So if it's decreasing, you need to put it in as a negative. We don't know our dx over dt. And then for x, what we can do is we can set up a little Pythagorean theorem at the instant that we're working with. This is x squared plus 36 equals 100. Or in other words, x squared is 64, or x is just 8. So we need to get dx dt by itself. I'm going to do this how I would suggest to think about it, since you won't have a calculator on the final. So if you divide by 2, those are gone. And then we'll divide both sides by 8. Well, the negative 400 divided by 8, 40 divided by 8 is 5, so that'll give you negative 50 times the 10 will give us negative 500, and our units are miles per hour. All right, we'll finish off with number 9, another related rates one. So sand is falling off a conveyor onto a conical pile. So conical means a cone at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. What is the rate? At what rate is the height of the pile changing when the pile is 15 feet high? So we know we're working with a cone. we got to think about what formula should we work with a cone. Well, the fact that we're given 10 cubic feet per minute, feet cubed means we're dealing with a volume. So we want to do our volume of a cone formula. So V equals 1/3 pi r squared h. So this 10 cubic feet per minute is a dV over dt because it's feet cubed. So V has to stay in the problem. We want to find the rate of the height. So that means height has to stay in the problem. But there is nothing in the problem that tells us about the rate of the radius. That means the radius cannot stay in the problem. So luckily they tell us something about the radius. They said the diameter of the base is 3 times the altitude. So d is equal to 3h. Well, diameter is twice the radius. So that means 2r is equal to 3h. And if we divide the 2 over, that means r is really 3/2 h. So we can replace our r with a 3/2 h. So if we square the 3/2, we'll get 9/4. And then 9/4 times 1/3 will give us 9/6, which reduces to 3/2. We'll have the pi, and then h squared times h will give us h cubed. So now we only have variables that we either, sorry, that should be a 4 on the bottom there, not a 2. So this was 9/4 times the 1/3 would give us 9/12, which reduces to 3/4. Sorry about that. Now we only have variables that we either know the rate, the v, or want to find the rate, the h. So we're ready to take the derivative. So we've got dv over dt. 3 times the coefficient out front will just give us 9 pi over 4 h squared times dh over dt. And the thing we wanted to find was the rate that the height was changing. So that's dh dt. So we should be able to sub in for everything else. dv over dt was 10 cubic feet per minute. And the gravel was falling onto it, so it's increasing. So that'll be a positive 10 in for dv over dt. Then we got the 9 pi over 4. They wanted us to find at the instant that the height is 15. And then we've got the dh over dt. So you could, since you don't have a calculator, you could multiply the 4 over and call that 40, and then just divide over the other stuff and call it 9 pi 15 squared if you wanted, since you don't have the calculator. Oops, this is a t. Or you could multiply that out. It's your choice, but this would be a full credit answer here. And we do need units. Height is a one-dimensional measurement. We had feet and minutes, so this would be feet per minute. Now, if you were to multiply it out some, this would be 40, this would be 9 pi times 225. Then you could take a 5 out of each of those. So that would be 8 over 9 pi times. 5 goes into each 100 20 times. So that's 20, 20, and then another 5 that goes into the 25. So that's, oops, that's 45. And then that would end up giving us 8 over 405 pi. And the easiest way to think of the 405, I think, is 10 times 45 would be 450. So 9 times 45 should be 45 less than 450, which is 405. And then you'd have your feet per minute. Okay, but that first answer we had would be perfectly fine as well. All right, so finish the rest of 1 through 9 and upload your work to Schoology.